All right, guys, today is notes 24-1, 24-3. It's not in your book, so you need your note sheet. Pause the video to get that note sheet, to print it. If you don't have a printer, just take notes on paper. Pause the video anytime you need as we're going along. Let's start with some vocabulary. We're starting a brand new unit, lots about circles. So here's some circle vocabulary to start. Circle, the set of all points in a plane that are equidistant from a given point. Now think about what that means. The set of all points in a plane that are equidistant or equal distant from a given point. So if I have this point and I go 3 inches away in every direction, you can see that creates a circle. The center is the point from which all other points are equidistant. Sort of the opposite of the definition we just did. Radius, you should have heard these next 3 words, radius, chord, diameter before, but we'll go over them. A radius is the distance from the center of the circle to any point on the circle. And here's a very good example right here, the center to any point on the circle. This is a radius. A chord, any segment whose end points are on the circle. So take a look. Here is a point on the circle and another point on the circle. And if I connect those, that makes a chord. It has 2 end points on the circle. A diameter is a chord. It's a special kind of chord. It's a chord that contains the center of the circle. So if your chord, here's our other chord, that did not contain the center. But if our chord does contain the center, it is called a diameter. Next, arc. Arc is a part of the circle consisting of 2 points on the circle and the unbroken part of the circle between the 2 points. If I have a circle and I pick these 2 points, this is the arc. It's the outside of the circle between those points. You could draw that if you want. We'll deal with arcs later. Secant and tangent. These are 2 brand new words, I would say. A secant is a line that intersects a circle in 2 points, or a tangent is a line that intersects a circle in 1. Let's look at this picture over here. You can see this secant line. It touches the circle here and here. It touches the circle 2 times. That's what it takes to be a secant line. And your tangent line is a line, but how many times does it touch the circle? Just 1. That's the definition of a tangent line. So there's your vocabulary for the day. And let's look at the 2 theorems. They're in a box. The first one has to do with a radius and a tangent. So let me read it. If a radius and a tangent line intersect, then they will blank. Well, let's draw it and see if we can figure it out. So draw any radius you want. We just learned what a radius is, from the center to any point on the circle. A radius and a tangent intersect. So I have to draw a tangent now. Now I can't draw this tangent because those don't intersect. I have to draw a tangent that will touch the radius. So it's going to have to touch in this 1 point here. If you have a radius and a tangent line that intersect, they will be perpendicular at the point of tangency. This is the point of tangency. Very important. We're going to use this theorem a lot. So anytime you have a radius and a tangent line that intersect, which our picture had in black, then they will be perpendicular. You'd be able to draw on that right angle symbol. The next theorem. If two tangents meet at a common external point, then they are congruent. Let's draw a picture so you can really see what I'm talking about. I need to draw two tangents that meet at a common external point. So let me draw this common external point. We'll go with that. I need to draw a tangent that touches that. And the second tangent that also touches that. What happens now is these two lines are congruent. From the circle to that external point, those parts are congruent. Okay, everything else today is pretty much going to use the vocabulary in those two theorems. Let's look at example 1. Tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent. So let's look at BC. Notice it stops at B and it stops at C. Otherwise, it would have said this. It says this. So I need to go to B and then to C. What is that called? That's called a radius because it's at the center and the other end is on the circle. Next one is, notice there's an arrow through E and going through A. So here's E and here's A. Notice it touches the circle 2 times. Look up at what vocabulary that would be. That's called a secant line. And finally, D through E. Here's D, I go through E. That touches the circle 1 time, which means it's a tangent line. Not necessarily the same thing we did earlier with sine, cosine, tangent. Sort of a different definition here when we're talking with circles instead of triangles. Number 2, use a diagram to find the given length. Radius of circle A. So here is the center of A. So this would have to be the points that are equal distant from A, and the radius is 2. The diameter is 4. I can erase that and do B. It's kind of nice to highlight the center and then all of the points that are equal distant from that, which makes your circle. Radius. Now this is a radius, but that's difficult to count that distance. So don't count that one. Find one that's easier to count. So maybe that would be easier to count. That's a distance of 4. Diameter, there's a bunch of diameters. Again, this is a diameter. That's kind of hard to calculate how long that is. This is a diameter. 1, 2, 3, 4, 5, 6, 7, 8. You could have drawn this diameter. There's a bunch to draw. Some are easy to count and some are not. All right, on the next page, tell how many common tangents the circles have and draw them. So if I draw this tangent line that touches the circle 1 time, that is not what we consider a common tangent because this circle has that tangent, the other one doesn't. I need to draw a line that touches both circles 1 time. That would be a common tangent line. It's tangent to the big circle, it touches the big circle once. It's tangent to the small circle, it touches the small circle once. Are there any other common tangent lines you could draw for that picture? This one would work. Any others? That line touches both circles 1 time. If a circle touches the line 1 time, it's a tangent line. And we want it to be a line that touches both circles 1 time. So there are 3 of them here. Go ahead, pause the video and do B and C. For B, there's one. And it's not drawn the best. Maybe I can do it a little better. There are two of them. 1, 2. Sorry, on the board it's not quite as easy. There are two common tangents here. This one, C, has only one common tangent on it. Example 4. In the diagram, RS is the radius of the circle. Is ST the tangent? Well, let me go back to this box we had at the front. It said if we have a radius and a tangent, they will be perpendicular. So when the question asks if it is tangent, it's going to be if they are perpendicular. So if these are perpendicular, then yes, it would be. So we have to figure out if this is perpendicular or not. Well, we just did an activity 20. We were able to figure out if three numbers made an acute right or obtuse triangle. And if this one makes a right triangle, which is perpendicular, then yes, it's got to be a radius and a tangent. So let's go ahead and do our smaller two first. So 10 squared plus 24 squared. Compare that to 26 squared. Remember, pause the video at any time if you're still calculating. They are equal. So this is for sure a right triangle. They are perpendicular. So yes, this is definitely a radius, which the direction said. And this is definitely a tangent. So yes, and here's my work. I showed that it is a right triangle. Number 5. In the diagram, B is the point of tangency. Find the radius. So they are telling you this is tangent, because that's the point at which it's tangent. And they're telling you this is the radius. If I have a tangent line and a radius, then, let's go back. If I have a radius and a tangent, they are going to be perpendicular. That's what that theorem says. So these for sure are going to be perpendicular. So go ahead at the place where they meet, draw a perpendicular symbol. Now that we know they're perpendicular, we need to find R, our variable. We're going to do the Pythagorean theorem, but be very careful. This is an important problem. Maybe put a star by this one. The reason this one is slightly different, you'll see as we go. Let's write down the Pythagorean theorem. Remember, A and B are your smaller sides, and C is your hypotenuse. So let's get started. Let's call 77 your A value. Let's call R your B value. Now, be careful with C. Look at your hypotenuse. It's 49 and R together. Again, here's 77. R is one side. The last side is this, 49 and R. So you need to write 49 plus R. Let's deal with the left side, the easier side for just, oopsies, I don't know why I put 7. Sorry. This is 77. This is R. I don't know why I put 77. This is, we're now ready for a calculator. Go ahead and type in 77 squared. R squared is just going to stay R squared. Let's go slowly through this part. You cannot do this. You cannot distribute the squared. if you distribute the squared, you would get 49 squared plus r squared. Okay, that is not correct. Let me show you how to do it the correct way. Remember, squared means times itself. So please write this times itself. I'm just going to recopy this again. Now let's distribute over here. Go ahead, 49 times 49. 49 times r. Now distribute the r. Another 49r. R times r, r squared. Notice that this is different than this. Some parts are the same, but we cannot just distribute the squared. That would only give us 2 terms. So just write it twice and then distribute it out. All right, so this algebra may look tricky, but it's actually going to clean up pretty nicely. Let's go ahead and recopy this side. Nothing to do here yet. Notice I have some like terms. 49 r's and 49 more r's. Add 49 to 49. Now, I need to get r by itself. There's a lot of r's. Let's move the r squareds to the same side. So I'm going to move this r squared over. I move it over, that's going to cancel there. What's nice is over here, it actually cancels also because I have r squared, and I subtracted r squared. Now look, now I only have 1r left. We know what to do from here. Go ahead and finish your algebra. Okay, there will be more practice problems like this. This is just the first one. The reason this one is more difficult, even though it's just the Pythagorean theorem, is because our triangle was 77 r, and our hypotenuse was 49 from here to here, and then r, which makes the whole thing 49 plus r right here, the triangle. So we put in 77 r, and the c was 49 plus r. So the setup is a little bit more complicated, and then the algebra has a few extra steps. Okay, make sure you have this so you can look back at this question. We'll do more like this in class. This is a good one to look back at. Let's look at 6. QR is tangent to circle C at R. So here's QR. It's tangent at R. And QS is also tangent to circle C at S. Find the value of X. Let's go back to our formulas from the very beginning. If I have 2 tangents that meet at a common external point, which is exactly what the picture in number 6 looks like, then these parts are going to be congruent. So this part equals that part. 32 equals 3x plus 5. Go ahead and solve that on your own. That's a pretty quick question. That'd be like 1 point. Last one. Example 7. In the diagram, RT is 12. RH is 5. and MT is 21. Determine the length of RM. Explain how you arrive. We don't have to explain, but we're going to show our work. This is not a right triangle. I don't have a radius and a tangent, so I'm not going to do 5 squared plus 21 squared equals c squared. It is not a right triangle. If it was, that'd be a great thing to do. Which theorem can we use to help us solve this problem? We have common tangents. We do. Look here. Here's a tangent, touches a circle at H, goes out here to R, and here's another tangent that also meets at R. These have to be the same length, so that is 5. Let's look up here. If this whole thing is 12, then I've already got 5. How big is this piece? 12 minus 5 is 7. What else can I label now that I know that part is 7? Well, here's a common tangent that meets at T. So both of these have to be the same, or both 7. It's kind of snowballing. Keep going, pause the video, and see what you can keep doing. Okay, you probably looked and saw this whole thing is 21, and you already have 7, so what would be left for this piece? 21 minus 7, 14. And there's another tangent that meets at M, that external point, so those are both 14. I can now give my final answer of this distance is 5 and 14, or 19. Okay, so once you know one common tangent, it just kind of keeps going. Just keep labeling and you'll figure them all out. Last one. If OH is 4, draw in O to H. Label that 4. Determine the length of OT. Explain. We don't have to explain. We're going to show our work. Well, I see that there's a triangle here. Maybe I'll draw it in blue. Is it a right triangle? Yes. Here's how I know. Because it says I have a radius, OH is a radius, and I know I have a tangent. Anytime I have a radius and tangent, they're going to be perpendicular. So go ahead and draw where the radius and tangent meet. It's perpendicular. I'm going to kind of redraw that triangle off to the side. This little piece was 4. This was 7. And this is what we're trying to find. Okay, we're working with this triangle, radius and tangent. I just thought it'd be easier to kind of draw it again somewhere so we can see what we're doing. Because they're perpendicular, we can go ahead and do the Pythagorean theorem. Go ahead and do that on your own. I'm going to call this question mark because it's here to here, OT. I'm going to call it OT. There we go. So that's the end of notes for today. We have some vocabulary. We have 2 theorems. Let's go back to those theorems. The theorems are if I have a radius and a tangent line that meet, where they meet will be perpendicular. You can see that led to a couple of Pythagorean theorem questions because it's a right triangle. And then our other theorem was if I have some external point, the 2 tangents that touch there, they will be congruent or same size. All right, go ahead and start your homework.